Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 9th, 2025, just yesterday. The standout claim is that a staged reinforcement learning curriculum unlocks parallel thinking in language models, yielding an 8.4% accuracy boost over a sequential thinking RL baseline and a 42.9% improvement on AIME25. The paper is titled Parallel-R1 towards parallel thinking via reinforcement learning, and the implications for model training are quite significant. In short, the method cold starts with supervised fine-tuning, then shifts to reinforcement learning that balances correctness and the use of parallel reasoning paths. Also, the authors shared a GitHub repository. Listeners will find a minimal placeholder with a README stating that code is coming soon, recent commit activity, and no releases or packages yet. The implementation is not available there right now, but the repository indicates ongoing updates and future code release. Figure 1 explains how the method turns parallel thinking into a practical skill during both inference and training. The top panel shows an answer flow that branches at a parallel tag, explores multiple paths inside path blocks, then writes a short summary, which means a concise synthesis that merges the paths back into one thread. The bottom panel outlines a staged curriculum that starts with supervised format learning on easy math, then moves through small-scale reinforcement learning, and finally, large-scale reinforcement learning on harder data. This progression matters because the model first learns the format, then safely explores, and ultimately generalizes. So the table quantifies why a cold start on easy math matters, because simple prompts yield valid parallel traces for GSM-8K, but not for DAPO. Table 1 shows that the model produced parallel formatted answers for roughly 83% of GSM-8K samples, while DAPO registered 0. This gap indicates that format learning should begin on easier data, then reinforcement learning can extend the behavior to harder problems. So Figure 2 shows how the structured attention enforces path isolation, which means each reasoning path only reads from itself and the shared summary so information does not leak. The red and blue zones indicate path window masking that blocks cross-path attention. The orange zone marks the summary block, which can attend broadly to integrate results. This setup matters because isolated paths support exploration, while the summary reconnects them for a final consistent answer. Table 2 compares training strategies and shows that staged reinforcement learning with parallel thinking delivers the best overall accuracy. Mean at 16 means average correctness across 16 sampled answers, and pass at 16 means at least 1 of 16 is correct. The Parallel-R1 scene variant leads the pack on average because it balances accuracy rewards with incentives to use parallel paths. Notably, AIME25 improves markedly under the unseen S2 schedule. Alright, 2 takeaways stand out. A staged curriculum unlocks parallel thinking as both an exploration tool and a later verification aid, and alternating rewards balance correctness with structured parallel traces, yielding sizable gains on hard math. The broader implication is a recipe for training models to reason by branching and reconverging. That is it for the AI Research Roundup. I am Alex. Thanks for listening.